Hi, very good afternoon to all of you. We are on the topic of the sum and product of roots of a quadratic equation. Now let alpha and beta be the roots of ax squared plus bx plus c. Now, assuming that you know the roots are alpha and beta, so we want to see how are we going to get from this criteria, alpha and beta being the roots of the quadratic equation, and we try to work backwards to form this quadratic equation. Now, alpha and beta being the roots of the equations, we can write it as x minus alpha, x minus beta. Now, if you look at it closely, if you multiply it out, you won't get this expression because the coefficient of x squared is a. Now, to make it the same, so we multiply it by a. And we can write this as ax squared plus bx plus c. Now, we expand this equation. We will have a into x squared minus alpha x minus beta x plus alpha beta, and that is equals to a x squared plus bx plus c. Let me do a close bracket here. This should be a square bracket. Okay, now if we divide both sides by a, so you got x squared minus, now x being common in these two terms, I want to factorize it out, so I have alpha plus beta x plus alpha beta, and I have over here is the left hand side I divide by a, so the right hand side must also divide by a, otherwise the equation will not be equal. Now there's a few things I want to show you over here. Now if you realize that what is alpha beta? Alpha plus beta is the sum of roots because alpha and beta are the roots of the equation. So you realize that x squared minus the sum of roots maybe I do a close bracket plus the product of roots. Now why I said product of roots, look at this. This is alpha times beta. Alright, this is alpha plus beta. Okay, and that is equals to x squared plus b over a x plus c over a. So we can say that the sum of roots is minus b over a, alright? So you can do a direct comparison, the x term and the x term. Okay, so sum of roots will be equals to minus b over a. Now what is the product of roots? This is the product of roots. Product of roots is c over a. Okay. Now what is important over here is this thing here and these two things. Alright. Now we will then move on to a few examples, and from that few examples we hope that you will get used to using the sum of roots and the product of roots to solve the problem sums. Now let's look at example 1. Example 1, it is given that 2x squared plus bx plus c has 4 and minus 7 as the sum of roots and product of roots. Find the value of b and c. Now, this sum, what we can do is we can make use of this equation that we learned earlier. So given that 4 and minus 7 is the sum and product of roots, so the equation we can rewrite it as x squared minus the sum of roots. Alright, x squared minus the sum of roots. What is the sum of roots? The sum of roots is 4 plus the product of roots plus minus 7. Alright, equals to 0. Now, but you look at it, the coefficient of x squared is 2. So we need to multiply by 2. Now, this is one of the equation that has the sum of roots as 4 and the product of roots as minus 7. So any multiples of it, alright, you will also have the same root, because this portion, alright, is the same. Alright, this portion will have roots. Okay, so if you factorize, this will be x minus p and x minus q. Alright, no matter what numbers you times over here, you will still have the same roots. Right? So this equation, alright, this equation has the sum of roots as 4 and product of roots as minus 7. So you just need to multiply a number to it, will still have the same roots whose sum is 4 and product is minus 7. So you multiply them out, you got 2x squared minus 8x minus 14. So what is the value of b? So b is equals to minus 8 and c is equals to minus 14. Okay, now let's move on to example 2. The quadratic equation x squared equals to k minus 1 times x plus k has negative roots which differs by 3. Find the values of each root and the constant k. Now, let's move all what is on the right to the left. So we express it in the form that is familiar to us. Now, they say that this quadratic equation has two roots, alright, which differ by 3. So let the roots be, let the roots be alpha and alpha by plus 3, because they say that the negative roots differ by 3. Now A, they are asked to find the value of each root. So we learn that the sum of roots is minus b over a. Alright, so your 1 is your a, this is your b, this one, just the k minus 1, and this is your, minus k minus 1 is b, and this is c. Okay, so sum of roots will be 2 alpha plus 3 will be equals to k minus 1. And then the product of roots will be alpha squared plus 3 alpha will be equals to minus k. Let's call this equation 1 and this equation 2. Now you are asked to find alpha and alpha plus 3, which are the roots. So looking at this equation, you use 1 plus 2, you will have alpha squared plus 5 alpha plus 3 equals to minus 1. Then you bring the minus 1 over, you got alpha squared plus 5 alpha plus 4 equals to 0. Now this equation you can factorize it. So you got alpha plus 4 into alpha plus 1 equals to 0. Now, so what do you get? You get alpha equals to minus 4 or minus 1. Now, please take note that this part of the question, that both roots are negative, has negative roots. So both roots are negative. So assuming that alpha is minus 4, alpha plus 3 will be minus 1. So yes, this we accept this answer. But if alpha is minus 1, alpha plus 3 is 2. Minus 1 plus 3 is 2. So the other roots is 2, so it cannot be. So we reject this solution. Alright. Therefore the roots are minus 4 and minus 1. Now let's move on to B. Now you're asked to find the value of the constant k. Now you know that alpha is minus 4 and k is this expression, or you can use this expression as well. I will use equation 1 because I don't like to square the number. So you have 2 alpha plus 3 is equals to k minus 1. So k will be equals to 2 alpha plus 4. Now alpha is minus 4. So you got 2 into minus 4 plus 4. So your answer is minus 4 for k. Now let's move on to example 3. Now we are given that alpha and beta are the roots of 2x squared plus 13x minus 7 equals to 0. If alpha is greater than beta, we are asked to find the value of the following expression. Now, one way of doing is you can solve this quadratic equation. Now, how to solve this? You can either complete the square or you can use a quadratic formula. This question, I don't think this expression can be factorized. So you can use complete the square or quadratic formula. And from there, you can work out all the value of all the 4 expressions. Now, but we are not going to do that. We are going to use what we have learned earlier. That's the sum of roots and the product of roots. And you can verify, after we have done that, you can verify by working out the roots of this equation and then against the answers that we work out, and you can see whether it matches or not. So without further ado, let's look at part 1. Now, Before that, let's write out what is alpha plus beta. Alpha plus beta is equals to minus 13 over 2. Alright. Now, and alpha beta, that is the product of roots, is minus 7 over 2. Now, part 1. Alpha squared plus beta squared. Now, we can make use of the identity. Now, alpha plus beta squared is alpha squared plus beta squared plus 2 alpha beta. So, you can just, maybe I just write it over here. Now, like this, alright? Alpha plus beta whole thing squared. Okay, you got alpha squared plus beta squared plus 2 alpha beta. You can just bring this over to the other side. So this will be equal to alpha plus beta whole thing squared minus 2 alpha beta. So you substitute this into the expression minus 2 minus 7 over 2. Now if you key this into your calculator, you will get 197 over 4. Now let's look at part 2. Let me use the same color as that. Okay, part 2. What is the value of alpha minus beta square? Now maybe we can just expand it. What do you get? You got alpha squared plus beta squared minus 2 alpha beta. Now what is alpha squared plus beta squared? Is 197 over 4. So this will be 197 over 4 minus 2. Alpha times beta is minus 7 over 2. So minus 7 over 2. All you have to do is you just punch into the calculator and you will get the value of 225 over 4. We have completed part 2. Now let's look at part 3. In part 3, you are asked to find the value of alpha squared minus beta squared. Now if it is plus, it's very simple. You can do it like in part 1. This is negative. But you look at it closely, this one you can factorize it into alpha minus beta into alpha plus beta. Now what is alpha minus beta? Is square root of 225 over 4 plus minus. Alright. Now, but you know alpha is bigger than beta. So you only take the positive of it, not the negative. Alright, I say again. You know alpha minus beta squared. So you want alpha minus beta. So you do a square root. When you do a square root, it has a value of plus and minus. But we only take the plus because alpha is greater than beta. So if you do a square root, it will be 15 over 2. Now what is alpha plus beta? Minus 13 over 12. No, minus 13 over 2. And if you multiply out, you get 195 over 4. Now let's do the last part of it. Now part 4. In part 4, we are asked to evaluate alpha squared over beta plus beta squared over alpha. Now let's combine these two and put it into as a single fraction. So the denominator will be alpha beta. So you multiply alpha over here because it doesn't have alpha. So you got alpha cubed, and this one doesn't have beta, so you must multiply beta, the denominator multiply by beta and the numerator also multiply by beta. So you got beta cubed. Now this one you have the value as minus 7 over 2. Now, so how do we find this value? Now, I think in school you all learn this identity. Now, this can be expressed as alpha plus beta, alpha squared minus alpha beta plus beta squared, okay, over alpha beta. Now, if you forget this identity is okay, because most of the time we hardly use this. Now, we can also do by, we can also derive by expansion. I will show you later. Okay, so what is alpha plus beta? Is minus 13 over 2. Now, this can be written as alpha squared plus beta squared minus alpha beta. So what is alpha squared plus beta squared? We have found it somewhere. Okay, we have found it here. So this will be 197 over 4 minus. Now what is alpha beta? Alpha times beta is minus 7 over 2. So this will be into minus 7 over 2 over minus 7 over 2. Now if you key this into your calculator, you will get 2743 over 28. Now in the event you have forgotten this identity, don't panic. Alright, just like this, alright, you want alpha cube plus beta cube, you can do something like that. So let us do an expansion of alpha plus beta cube. What do you get? Now, if you know binomial theorem, you can expand this using the binomial theorem. Alright, otherwise you can expand it this way. Do the square first. Alpha squared plus beta squared plus 2 alpha beta. Alpha plus beta. Okay. So you got alpha cube plus alpha squared beta plus beta squared alpha plus beta cube plus 2 alpha squared beta plus 2 alpha beta squared. Now, this is this that we want, right? Alpha cube plus beta cube. Alright, so we group them together. Alpha cube plus beta cube. Now, you look at it properly, there's two like term here. I mean, these two are like term. And these two are like term. Okay, so we add all the like terms together. So you have plus 3 alpha squared beta plus 3 beta squared alpha. So you can re-express this. So alpha cube plus beta cube will be equals to alpha plus beta cube minus these two. Alright, minus. But these two that's common, alpha and beta is 3 alpha and beta is common, so I can factorize them. Alpha plus beta. Alright, so you know what is alpha plus beta cube, alright, because you know what is alpha, and then minus 3, you know this value, alright, and then alpha plus beta, again you can substitute this value inside. Okay, so you will find that this answer will be exactly the same as the numerator of this. Okay, now we have one more example to go, and we have now come to example 4. Now this question is a bit tricky and you need to be a bit creative. Now alpha and beta are the roots of x squared minus 5x plus k. You are asked to find the value of alpha squared plus 5 beta in terms of k. Now, one way of doing it is you try to solve this equation, alright, in terms of k, and one of the root will be alpha and one of the root will be beta. Then you just express alpha squared plus 5 beta in terms of k, because you already found the roots, so your alpha and beta are already in k. That is one way, but that is a bit long, alright, compared to what I will be showing it to you. Now let us begin. Now if alpha and beta are roots of this equation, that means alpha squared minus 5 alpha plus k equals to 0, and beta squared minus 5 beta plus k must also be equals to 0. Now because they are the roots, so they will definitely satisfy this equation, because this is a point on the curve, on the function. Now you look at the first equation. Actually equation 2 is kind of redundant, but I just write it to show it to you for illustrative purposes only. Now, so you have alpha squared, you bring all this across, you will be 5 alpha minus 5 alpha, no sorry, plus 5 alpha minus k. Okay. Now you want alpha squared plus 5 beta, so you plus 5 beta to both sides, so you got alpha squared plus 5 beta. So you have 5 alpha plus 5 beta minus k. Now what do you realize over here? This one is actually the sum of roots, alpha plus beta. Okay, but what is the value of the sum of roots? Now from here, okay, so alpha plus beta, alright, this is the negative sum of roots, so this will be 5. Alright, so you substitute 5 inside here, so this will be 5 into 5 minus k, and that will give you 25 minus k. Alright, for that we have come to the end of this video. If you like our video, please subscribe. Thank you very much and have a nice day.